there I also explain or introduce one more keyword that are associated with the topic is called as regular expression. Okay, so we'll have a discussion of regular expression as per today's class, and we'll see what is regular expression, how we supposed to use it, and what is the use of it. We'll see. Okay, so very simple. I already told you, whenever there is a language. Okay, wait, I'll increase the cursor space. Okay, whenever there is a language consists of collections of string. So instead of specifying the collections of string like this, I wanted to specify the same with some shorter notation. The shorter notation is called as a regular expression. So now what is that meaning? Instead of giving the language with the collections of string, they will be given a language in terms of regular expression. Okay, so a regular expression given to you. What you supposed to do? You have to draw the corresponding finite automata for the regular expression. So that is the conversion of regular expression to finite automata. Why we need to do this conversion? Because having given any language, our purpose is to construct the finite automata. Once you have construct the finite automata, then the string that are belongs to the regular expression, you have to test it over that finite automata. That is the overall procedure we learned from our last 10 classes. Okay, so now what I try to say from this picture is, you can clearly note on this. If you want to do that for a given language for a finite automata, here the language will be given in terms of regular expression. Then you have a two option to design your finite automata. Whether you can draw the deterministic finite automata or you can draw the non-deterministic finite automata. Now the question is, which one you going to draw? So okay, which one you want at last? Finally, you want DFA only. Now you may think that for a regular expression to DFA conversion is only the thing we want. From the DFA, I have to give the input and I have to test it. But whether the regular expression to DFA construction is possible or not, that is the question. Okay, so we don't have any dedicated algorithm to do this. Okay, and we don't have any direct procedure to do this. That is the reason we are first convert any regular expression to non-deterministic finite automata, and from that we will convert it to a deterministic finite automata. So for this conversion, for a NFA, we have the NFA to DFA, we have a dedicated algorithm is called as a subset construction algorithm that we have discussed in the last class. Now we will see this regular expression to NFA conversion. By the way, the regular expression can be converted to NFA. With that, we have a two type one further. The NFA, one more time, it will be divided as epsilon NFA, and another one is direct NFA, normal NFA itself. Then you can consider this one. The regular expression can be directly converted to NFA, regular expression directly converted to epsilon NFA. Now the question is, either the regular expression converted to NFA, either the regular expression converted to epsilon NFA, our ultimate aim is we need to convert it to DFA. So whether it is directly NFA, subset construction algorithm, whether it is epsilon NFA, there also we have a two option. One is the epsilon NFA, one is a subset construction algorithm. Another one is the subset construction algorithm we have to do with the e-closure procedure. Okay, so there is a one more sub portion is called as a epsilon closure procedure. So upon performing this procedure to construct the subset construction, to construct the subset, and we have to convert the DFA. So what we are going to discuss in this rest of the portion is what is regular expression, how it will look like, how we can be able to convert the regular expression to epsilon NFA, and also we will going to study how we have to convert the regular expression into NFA also. Okay, so this is what the discussion of this. Once you have constructed the epsilon NFA or NFA, then NFA to DFA we already did. So the rest of the thing we are going to discuss in this rest of the portion is epsilon NFA to DFA conversion. Okay, so now is it clear now? So the language will be given in the form of regular expression. For that, you have a two option. Either you can directly convert NFA, from NFA you can construct DFA, one option. Second option, from a regular expression, you can apply the Thompson construction algorithm to construct the epsilon NFA. From the epsilon NFA, you can construct the DFA. So both the thing we are going to do with this unit. Okay, so first we will explore about regular expression. In what way the regular expression will look like. Generally, if you go for a regular expression that are going to describe the regular languages, then what is the regular languages? The language will have a finite automata, then those languages called as a regular languages. Then only for the regular languages only we can express the regular expression. So what other language we cannot able to express the regular expression? There is a language is called as a context free language. We cannot express the regular expression. There is a language is called as a context sensitive language. We cannot express this language in terms of regular expression. We have something is called as a recursively enumerable language. For those languages also we cannot able to write the regular expression. So the regular expression we can able to write only for the regular languages. First point. Second, as you can see, as the regular expression is a concern, what are all the things are there in the regular expression? There are three computations are there in the regular expression. Okay, so the one first thing is called as the union. Okay, generally the union will be represented either by plus or either by this vertical bar or either by this comma. Both will represent that union. Second, concatenation. The concatenation either will be represented in two form. One is the dot between two symbol or without dot. So this is the way the concatenation will be represented. The third functionality which is available in the regular expression is called as this closure. Okay, so this is the closure we will call it as a clean closure. Okay, clean closure. So these are all the three operations available in the regular expression. Okay, so now we have to explore how this operation will look like. Again, I'll tell you these operations are, excuse me, not new for us. We have already seen those operations in the earlier stage itself. Okay, so I just recap those operations. Okay, first, whenever you can see there is a closure, clear, and as you can see the closure for what, the whole information, the whole set. For this whole set we will call this the whole language. Now the language will be represented by the regular expression, and this is the language I can call it as a regular language. Now what is the information the regular language has? It has one symbol and there is a union operator, and there are two symbol in the concatenation operation. Put together we have a closure. Then what is that meaning? Whenever there is the union, then either you can take a left hand side information or right hand side information. Either if it is a concatenation, you have to take all the information put together. Either if it is a closure, then we have to identify the combinations. It means a repeated combination. So now we will see if you go for a closure. So always the closure will include the lambda as a string. Then what I'm going to do here, I have mentioned the equal symbol, no? Then this is the actual regular language. These are all the strings of the regular language. Even this could be written like this. So that's why I tell you this word, shorter notation of the regular languages. So here I know that the right hand side is the languages. This is the shorter notation of the languages. So what language is this? This is the regular language. Clear? So now, what is the meaning of closure? It will also include lambda. It means empty string is also accepted. Okay. Then what are all the strings may be available here? Between these two, we have what operation? Union operation. It means what? Either I can take A, or either I can take BC, or either I can take two time of A, either I can take two time of BC, either I can take one time of this and other time of this. So either I can take one time of this, other time of this, either I can take these three times and this one times. All possibilities between these two will have. But one important thing is, as this with respect to union operation, but you can see the concatenation, we ever separate this BC. Always the BC will together. It means what? B followed by C will have an operation is called as concatenation. So concatenation you cannot separate. For union only you have an option. Okay. So now you can see the basic things. These are all the primitive regular expression. Which one? Empty string, null set, or a single input. These are all the I mean I can say that all possible regular expression. Okay. One is union, concatenation, closure, or representing the individual element in the parenthesis. Okay. So now we will see one by one. See here. Here what is your understanding? Here I have a regular expression. Between this component and this component, I have a union. Between these two components, I have a concatenation. Put together, I have a closure. Okay, and between these two components I have again concatenation, and between these two I have a union. Okay, so this is what the way the regular expression will be represented, and this is not the regular expression because the union between two symbol, or we will call this between two string. But here you can see A and B is fine. Then what about this plus this union with what? There is no proper input, no, so this is not considered as the regular expression. Okay, so next, whenever we have a regular expression, definitely the regular expression will have only for one languages. That language is nothing but a regular languages. Okay, then what is the meaning of this one? Again, I'll tell you. L, what is that language? The language can be represented in the starter notation. What is this regular expression? So this is what is the meaning of this? This is the meaning of this. So instead of writing like this, I will be writing like this. So this is the understanding which I supposed to receive from the regular expression. So literally this is the shorter notation of these languages. Clear? So next, whenever if you go for regular expression, okay, so there is a language will have a null set. Then what is the collections of string? Null set only. Whenever we have a lambda, then the lambda is also, I mean, whenever there is a lambda, then lambda is the input. Whenever we have a regular expression is a, then what are all the strings of the language? A alone. Now you can think. Whenever we have the languages of R1 and R2, then this is the meaning of L of R1 union L of R2. Then what is the meaning of dot concatenation? What is the meaning of closure? L of R1. So how I can able to explore this? From this I can able to explore. Previously, you can see here, having given regular expression, I have constructed the strings that are belongs to the language, right? So now you can think about this, how we supposed to identify those strings, how I supposed to compute the strings that are belongs to the languages. So I wanted to do that, right? How to do that? Let's, you can see here you have a regular expression which is belongs to what? This is actually what representing the languages. Now I wanted to split this for better identifying the strings of this. So first L of a plus b. No, so put together here we have one parenthesis. So this alone I have to take it as a separate language, and the remaining a star I say take it as a separate language. And between these two, what operation I have? Union operation. Then L of a is separate component, L of b is a separate component. Then what is this L of a star? L of a star will be written like L of a whole star. So I can write like L of a whole star. What is that meaning? All combination of a. Okay, so which is that with the operation of concatenation. Now I can come to left hand side. L of a is what? Only one input. One input means what is the answer? A alone. The same way L of b means what? Only one input. B alone. Union of these two what? A comma b. So this is a separate component. Now I can come to a star. What is a star? Including with the lambda, all combination of a. So all combination of a. Between these two, what I have operation I have? Concatenation operation. Then what you can do? Take one, multiply with all. Take this, multiply with all, then you can formulate the final string. So now a multiply with the lambda, a only. A multiply with the double, another a, double a multiply with the double a, triple a. Like this the a multiplication will goes. Next b multiply with everything, it will goes like this. Then this is what actually the collections of string for this language. So both are same. This is actually equal to this. How I can able to do that? How I can able to confirm? Because actually these things supposed to be there inside this L, but instead of writing this I can see that the very large in space, I wanted to rewrite in the shorter notation, that is this regular expression. Okay, and as the regular expression is concerned, we have only three component: union, concatenation and closure. Okay, if you know these three, then you can write your regular expression for any given languages. Okay, so now you can see one more regular expression. A plus b will have a star operation with I mean a plus b will have a closure, and a plus b we have a union. Then what is the answer? Here what we will get? Here we will get lambda a b, 2 times of a, 2 times of b, a followed by b, b followed by a, and this whole set will be multiplied with what? Here you have only two combination. One is a, another one is bb. So now you can take this and multiply with this. Take this, multiply with this. Take this, multiply. So if you do like this, then you can form this as a collections of string. So definitely minimum 1a is possible. Okay, now I will ask you someone, what is the minimum accepting string of this language? Minimum one string will be there. So what is the minimal accepting string of this language? Young engineers, come on. What is the minimal accepting string of this language? Okay, here if you put lambda, this is over. And for this, at least if you take minimum 1a, then lambda multiply with the a is small a. So the minimum accepting string of this language is small a. Okay, so now you can tell me what is the minimal accepting string of this language. Okay,
B,
what?
sir.
Say it's okay. Then what way the same language you can call? Can I say in that way? Always the language will end with minimum 1b. Am I right? Am I right or wrong? Always. Definitely this b is definitely there, right? If I take both lambda, I will get minimum 1b. If I take here, I will take 1 times. Then I will get 2 times of a, 1 times of b. If I take here 1 time, then I will get 2 times of b, 1 time of b. Then if I take this is 2 times, then I will take 4 times of a, 1 time of b. I will take here 4 times, 4 times of b, 1 time of b. Here I will take concatenation of these two. Then I will get double a, double b also. So anyhow, I can see minimum 1b at the end. That is the string of this particular language. Now what is this? This is another one regular example. I mean regular expression. Even this could be represented like this. So for this notation, we don't have any specific name for the notation. Only this notation I can call it as a regular expression. This is a formal notation only. Okay. Now this one, tell me what is this? What is the language is this? Oh, you are expecting me to say that command language is just like that every time. You can do. See here, 0 plus 1 will comes under the closure. Then definitely lambda. 0 plus 1 comes under closure. Definitely lambda. So the minimum accepting string is 0, 0. So minimum is supposed to give the facility for 0, 0. Okay. So that minimum accepting string of this language is 0, 0. Then if you take 1 0 here, 2 0 compulsory. And you can put lambda here itself. You can take 1 1 here, 2 0. Here you can take 0 and 1, 0 0. By the way, all the time I put this as a lambda. Then here also I can take the combinations. So this is what the way the string of the language will be formed. Okay. So now this one, what is the minimum acceptance? This could accept lambda also, right? Am I right or wrong? Here we have a closure. So put together it is a lambda. Here I have a 0 plus lambda. So here you have a union operation. So either lambda or 0 or combination of 0 with. So always if you do that, minimum acceptance is lambda. Followed by all the way you have multiply with the lambda, you will get only that result only. Single 0, double 0, triple 0, like that. Okay, so now I'll come to this regular expression. The same way, whenever you have a two regular expression, both will produce the same language, then you can say that both are equivalent. Okay, so now you can see here. Here I have one language, I mean regular expression. Here I have another regular expression. Both will produce the same language. What language? See here, all string with at least two consecutive 0. Is it true? Can someone will say that the string of this language? Tell me. Okay, at least you say that both will produce the same set of languages. See here, this alone will have a closure. Between these two, we have a concatenation, and this put together not have a closure. Only for this alone, we have a closure, and for all the thing, we have a closure. Here, these two in the concatenation. Here, it is a union. Here, it is a closure. So now, what is a minimal accepting string here? If you put here lambda, here only one you can take. So minimum will get what? Lambda. Otherwise, 0. Otherwise, 0 lambda. Otherwise, 0 0. Otherwise, lambda 0. Right? You can think the same way for this. You have to note down this. The next class you can tell me the string of this language. I will ask someone. You're supposed to show your computed result in your notebook. Note down the second one. 1 star 0 1. 1 star whole star. Otherwise, you can take a snapshot. Okay, I'll take you to the next discussion. So now, as of now, I have discussed about what is mean by regular expression. Okay, so now I have a discussion for regular expression to deterministic finite automata conversion. This is what I already told you. That is what my purpose. For a given regular expression, I need DFA only. So how I can able to construct? That is the question. Okay. So before that, I already told you we cannot directly do that. Either we have to convert epsilon NFA, from that we have to apply the subset construction algorithm, or we have to construct the NFA, from that we have to convert to the DFA. So the subset construction algorithm is the procedure for both the scenario. Okay. So first I will go with the solution for converting any given regular expression to epsilon NFA. So to do this conversion, we have a dedicated procedure which has been proposed by the person is called as a Thomson. So the name of the algorithm is called as a Thomson construction algorithm. Okay. So how to do that? What is the procedure? Accordingly, we have to do for this one, right? So after that only we are going to apply this. See, this is the NFA to DFA conversion. Here first we will see regular expression to NFA conversion using Thomson construction algorithm. So what is the algorithm says that whenever you have a single notation like this, then you can directly use two state and make a transition. The first state is a starting state, the next state is the final state. Next, whenever you have a two symbol having the concatenation operation, then for one symbol you have a one transition, and between these two concatenation you have to introduce the lambda or the epsilon. Both are meaning that the empty string only. Okay. Next, after that you have to introduce the second symbol. So this is the structure you have to follow for concatenation. Next, or that is union. So I already told you it may be a vertical bar, it may be a comma, it may be a plus. Both will represent, all will represent that union only. Now, what is the way you have to represent that union? Whenever you have a union, the left hand side component with the one portion, right hand side component with the other portion. That's why you can imagine that whether I can take left or right. So if I take left, then from a state, without reading anything, I will go to one state. From that state, I will do the left hand side computation. Then I will go to final state. If I take the other one, then from a state I have to take the other direction. With the empty move, I'll go to one state, and reading the next option, I will go to the other state, and reading the empty string, again I'll go to final state. So what this will give, a comma b is what is this language of the regular expression? Okay, it will maybe a single a or single b or two times of a or sorry. So here you have only one option, right? Only these two options. Why two times of a? Because if it is closure, then only all possible combination delta star, sorry, sigma star. Here we have only two options. Either I will take a or either I will take b. So this is the only string belongs to the language. So from a state I can take a, I will go like this. From a state I can take b, I will go like this. Okay. Now why I said this is NFA? Because the explicit representation of lambda is possible. One point. Another point, As I can see, there are two symbols, but not all the symbols will have a transition of both the symbols. Only these two symbols are having, the other symbols are not having the other, I mean, other states are not having the transition for these symbols. That is the reason I can come to the conclusion that this is definitely NFA. Then why I can call the epsilon NFA? Because there is a structure which you are following for union, concatenation, and the normal string as per the Thomson construction procedure, right? So always there is a procedure to add the epsilon to form a structure as per the rule given by Thomson. That's why here the NFA will called as the epsilon NFA. So please don't confuse with the symbol epsilon. The epsilon is a symbol which is equivalent to lambda only. Okay. So now we can come to this closure that is very, very important. What is this A star? A star is the lambda. A star is a single A. A star is a double A. A star is a triple A. A star is the all combination of A. Then how to do that? From a state with the empty transition, I can go to final state also for lambda. Fine. From a state reading single A, I can reach final state. So for that reading single A, I have this structure. Lambda followed by a state. Reading A, I will go to other state. Then reading lambda, I will go to final state. Or you want to read double A? No problem. For a single A one time, and with a lambda transition, I mean epsilon transition, I will back to this state. Again one more A. Then I will go to final state. 3A, 1, 2, 3. So what is the result you will get? For a first time, epsilon A, this one, epsilon A, epsilon A. So multiplying with the epsilon with any input, what result? A only. A multiplying with the epsilon, what result? A only. A multiply with the concatenate with the A, what is result? Double A. Double A concatenate with the epsilon, what result? Double A. Double A concatenate with the A, what is the result? A. So finally you will get a 3A. Okay. So this is what the way the primary three regular expressions are converted to epsilon NFA. Now, sir, the question is DFA. Why don't we directly think? Huh? Now you can think for this. Now think for this 1 plus 0 1 whole star, or I can even go to the simple one. Now think for this. Write a DFA for this. Minimum you have a single A, right? So a minimum single A is accepted. Okay, single A is accepted. I'll go to final state. This is starting state. Then double B, you have one B followed by another B. You will go to final state. Okay. Then any combination of A B, you can think about this. Any combination of A B before that. Then you have to do like this A comma B. Then you have a two transition of A from the same state. Then it is become as a NFA. By the way, there is no any direct procedure to draw the DFA. That's why we have a NFA followed by DFA conversion. So how I can easily draw the NFA for this? Very easy. I'll be there in the state is called as a Q naught. So what is that? A plus B star. Star means what? Repeated. So in the self loop, I can put A plus B means it is equal to A comma B. A comma B. Okay. Next, what here I have a R option. After reading this, either reading A, I will go to final state, or either reading B, I will go to one B followed by another B, I will go to final state. Anyhow, these two will have only one option, A or BB. That's all. So that will perform the concatenation operation with any combination of AB. So after reading AB, either reading A, I will go to here. Either reading B, I will go to, either reading BB, I will go to here. That's it. So this is the diagram I can call it as a NFA diagram, because from Q naught, I have a DA transition here, A transition here also. From a Q naught, I have a B transition here, B transition here also. That's why it is NFA. But it is easy for me to convert the DFA using subset construction algorithm. Now you can think about how easy it is to draw the NFA for a given regular expression. Now this is what actually we are studying here. No, we are studying the other way of writing NFA, that is epsilon NFA as per the procedure, as per the structure. The thing which I have written there is the direct NFA, not the epsilon NFA, or it will not apply the Thomson construction algorithm. Both have a different concept and don't get mixed. So there are two ways. For a regular expression, applying the rule you can write or directly write. Both are fine, because anyhow we need a DFA for epsilon NFA to DFA or NFA to DFA. The algorithm is common only. That is the subset construction algorithm. Okay, so let me explore more. Single A, single B, single C, fine. Now you can think about this B or C whole star. So first you have to think about how you can draw for B or C. See here, from a state, if it is B, I will go here. If it is C, I will go here. After reading B, I will come to this state. After reading C, I will come to this state. So this is the only portion for B or C. Now what I have added, the BRC will have a repeated mode. So star. So star means what? From a starting state, directly I can go to final state. Or this BRC will be repeated. Where we have a BRC, this is the BRC portion, right? So this will be repeated. Then where I have to put the repeat from here to here, you can put the repeat for lambda. Now you can explore the string of this language. Can someone please unmute and tell me? Previously, you have seen the string of the BC. That is only B, only C here. Sorry, AB. Now you can tell me that BRC whole star string. Come on, young engineers, come on. What are all the BRC whole star strings? Anybody is there, or I'm simply speaking alone? Hello? 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 Dear students, am I audible? Can get my point? What is the BRC whole star language strings? Then if you tell me the string, then I can test it with this diagram. Okay, so I'll tell you. BRC whole star. Star means lambda also accepted. So yes, this is the starting state. Reading lambda, I mean reading lambda or epsilon. Okay, epsilon I can reach final state. Okay, single B accepted. Yes, from epsilon, epsilon, single B, epsilon, epsilon, single B accepted. Okay, single C accepted. Epsilon, epsilon, C, epsilon, epsilon. Okay, and two times of B accepted. How? Epsilon, epsilon, B, epsilon. Again come back epsilon here. Epsilon, B, B. Okay, two times of B. Two times of C. Okay. One time of C. Self loop. Another time of C. B followed by C. Super. For B, this loop. For a C, this direction. CB. For a C, this direction. B, this direction. Then yes, you are right. So this is the diagram for BRC whole star. So what is a BRC alone that we have already seen? This is only for BRC. This is BRC whole star. Now, A concatenated with the B, BRC whole star. Then here we have a three component. No, all three regular expression come to the picture here. How to do that? Very simple. A, the put together what operation concatenation. So single A, epsilon, epsilon, then the rest of the portion here. So the rest of the portion what will have BRC. So from the position here is a BRC. Then BRC we have a whole star. So this state to final state and there is a loop. That's all. A into BRC whole star. So this is very very important. You supposed to know how to draw this diagram, because I will give you only the regular expression. I ask you to convert the DFA means you first construct the epsilon NFA like this. Then you have to apply the subset construction algorithm to convert it to DFA. Or some situations having given regular expression, you can directly convert NFA, apply the subset construction algorithm to construct the DFA. So this portion we already covered, NFA to DFA conversion. Only the epsilon NFA to DFA conversion we are not covered. We are not aware. That we are going to see, okay, in the subject. So now instead of so now we got the structure. Now we are going to apply the structure. A plus B. What is the epsilon NFA? Okay, A plus B, I'll tell you. Starting state, OR operation, no? A plus B means for a A this one, for a B this one, that is OR operation. Both will finally end it with this scenario. Okay. So now you have an arrow like this. 1, 3, 4, 5, 6. So this is A, this is B. Then what are all the other state? So this is epsilon, this is epsilon. You can put lambda also. Both are fine. Both are right only. Epsilon. Then you have to give the state name Q naught. Now it is very important. The way you have to give the state name. Start from here, go to top, then you can come to bottom. Q naught, Q1, Q2, Q3, Q4, Q5. So this is what the way I draw the epsilon NFA for this particular input. Now someone will say about AB, how to draw the AB from a state, starting state. After reading single A, I will be there in one state. And between the concatenation, I have to introduce the epsilon. Then I have other state, that is the state will going to reach final state. Now here you can put this is state Q naught, sorry Q naught, Q1, Q2 and Q3. Now you have one more facility. Whenever there is a concatenation, you have an option that it is not explicit to specify the epsilon between the concatenation, because anyhow in the concatenation the strings are cannot be separated. So definitely it cannot be separated means you no need to worry about introducing the epsilon always between the concatenation. So the same thing can be written like state reading A, I'll be there in one state. From the state reading B, I'll be there in the other state. So this is also right. Directly right. Perfectly right. But this is only the NFA only. Definitely not the DFA, because what about the transition of B for these three states? For this state, no, there is no B. This state, there is no A. This state, there is no A and B also. So whenever we are missing them, then we know that implicitly it will go to pi. So which kind of a mission we are doing that only for NFA? So definitely still our task is not completed. We have to convert this into DFA. Right? Then why we can go for regular expression? Because the language can be represented in the efficient way only in the regular expression. Our task to find the mission for the language, so we need to do the conversions. Okay, and what about A star? Very simple. I already draw from a starting state. I can directly go to final state, or one time of A, or any time of A. So these are all epsilons. So this is a starting state, this is a final state. This is a Q naught, Q1, Q2, this is Q3. What is this parenthesis of A? This is nothing but a simple A only. So there is only one starting state, one final state, and there is a transition of A. That's it. Then what about this? I don't think that whenever there is a complex, I'm asking you. No, not like that. I will do, no problem. I'll be very happy to do that. 0 plus 1 whole star. Concatenated with a 1. Concatenated with a 0 plus 1. Okay, I'll do. First what we have R and star. Okay, I'll start from here. First I will complete the R. This is the structure of the R. This is the structure of the R. And the R will have where inside the R will have a star closure also. Closure means we have to add one befriend, one end. So is there anything else? No, this is a starting. Then you can put this is a starting state. Reading epsilon, I can able to go this state directly. And reading the epsilon and epsilon, I have a two option. One is a 0, another one is a 1. After reading 0 or 1, I will go to this state, or sometime this 0 1 get repeated because of star, because of this star. So now you can see Q naught, Q1, Q2, Q3, Q4, Q5, Q6, Q7. Again, you have to be very careful what way I'm giving number. If it is the structure like this, you have to give the number in this direction. Then you have to give the number in this direction. So what operations is 0 plus 1 will have with the one concatenation operation. So I will put one epsilon and I will put one transition. So what is the number it is? It is Q8, Q9. Then again, what transition we have? Only concatenate with what? 0 plus 1. So again, we have a concatenation. So epsilon, and we have what? 0 plus 1 option. So again, you can see here, from this we have a, okay, I will write this once again here. Okay, so to avoid the confusion, so you can imagine that the arrow is coming from there to here. If you see here, then here you have a R option. That's it. R option consists of what? 0 and 1, because 0 plus 1, no? So this is epsilon, 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 and this is the arrow direction. Then which is the final state? This is the final state. So can you please, someone will tell me what is the minimum accepting string of this language?
One zero.
Very good. Otherwise?
One one.
Very good. So you can check here. From starting state, I can bypass everything here, and reading single one, reading single zero, I can reach final state. I'm bypassing everything, reading one, reading another one, I can reach final state. So the minimum accepting string is either 10 or 11 is the minimum accepting string of this language. Okay, so with that, I'll hand over this to you. ARB whole star ABB. How to draw this? Can I draw here? Okay, I don't have a space above. I will take this one. ARB whole star ABB. So what I wanted to do, I want to convert NFA. Direct conversion I can do, but the restrictions which has been given to me is I need to apply the Thomson construction algorithm. If I apply the Thomson construction algorithm, I can generate only epsilon NFA. What is the direct NFA then? I can try closure. Closure with what? ARB. Okay. From a starting state, sorry, from a starting state, I have ARB in the closure form. So closure means self loop. ARB means comma. Concatenation means you have to make a separate state. A, B, B. Final state. That's it. What is the diagram is this? This is a Q0, Q1, Q2, Q3. So this is the diagram is called as NFA diagram. Whether by drawing the diagram, do I have any procedure? No, I don't have any procedure. I'm just simply understanding. I'm drawing according to this language. I'm just draw this. This is a pure NFA. We can apply the subset construction algorithm to convert the DFA. But the question is, we have to construct the apply the Thomson construction algorithm. Then we cannot generate NFA. We can generate only epsilon NFA. How to generate? That's what we have seen as of now. So now for the same input, what we have to do is apply the Thomson construction algorithm. Okay. See here, lot of example are related to that only. Okay. So I spend much space for this regular expression to finite automata, especially finite automata means epsilon NFA conversion only. Okay. So I'll take a few more example. With that, I'll stop this idea and I will move to the next discussion. So I will complete this one. ARB ABB. Very simple. ARB ABB. ARB whole star, right? So okay. This is the structure for ARB, and this is in star. So starting to ending, we have a self loop. Okay, so this is a A, this is a B. ARB whole star followed by ABB. Okay, concatenation with a single A, concatenation with single B, concatenation with another B, final state. This is the diagram. You can fill the states here. This is a starting state. This is a final state. 0, Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, Q11, Q12, Q13. That's it. This is the diagram of ARB whole star ABB. What diagram? Epsilon NFA. From that, what I have to do? I have to convert the DFA. Okay. Let me explore more you can practice these things, very easy things. I have a some more example. Okay, so let me complete that, then I can come to this slide. What is this slide talking about? I will come to that. Okay, this alone, a star, a or b concatenated with the b, sorry, a star concatenated with the b. What is that meaning? A star starting state, a direct transition of epsilon. So here I have single A, one possibility. Second, concatenated with what? B. So for the concatenator, I have added one more epsilon. Okay. Then I have a plus B whole star. Super. So now you can see here structure A plus B. Yes, this is a plus B. But this is also have a star, right? So from the previous state, I have to go some final state. Here only there is a connection. Then this is the final state. So now this is the overall diagram for A star concatenated with the B concatenated with the A plus B whole star. So here you have a AB, here you have a plus whole star, here you have a B, here you have a star. Okay. So now this one AB concatenated. See here there is a different. Here the whole star for this concatenation. Here the star only for B. How do you differentiate this? Very simple. AB in concatenation, right? Anyhow, A and B will become one after another without disturbing any other. So A and B in concatenation. But we have a star. So what I have to do for a star? The starting state maybe this will go to this state with the epsilon, and this A and B will be repeated n number of time, infinite number of time. Here epsilon, here epsilon. So this is the AB whole star. What about multi concatenated with the single A only? No, concatenated with the directly A, and again we have a B. So again we have a B star. So that's why here we have a B star epsilon, 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 and this is the final state. So this is the AB whole star. This is just B star. So between that we have a A. Now we may ask, sir, here and here we have a concatenation. Here and here we have a concatenation. Why you are putting the epsilon between these set with this and this set with this? That's why I told you putting that concatenation. Whenever there is a concatenation, definitely one after another is mandatory. So no need to give a lambda. Whenever we are giving a lambda, it will bypass. From this I can, instead of going this, I can bypass. From this, instead of going this, I can bypass. Okay. So now about this, because I don't want to continue this discussions in the next class, next discussion, from the result of epsilon NFA, I wanted to do the DFA. So finally, I wanted to test with this one. Okay. So we have a R, right? R and. So between these two, I have a R. So definitely the branch will go like this. And bottom I have a BA. So this is for a B, this is for a A. So this is for a A, this is for a B, this is for a A. This is A plus B, and it will be in the what pattern closure. So directly here I have, and self loop I have. So this is a starting state. This is what overall A plus BA whole star. And finally we have a concatenate with the BA. This is B, this is A. And what are all the empty portion? Epsilon, 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 epsilon. That's all. Here epsilon. Then direction, this direction. What is a minimal accepting string of this language? Small ba. So from a state bypassing everything, I will come to here. Reading B, I'll be here. Reading another B, I'll be there in the final state. Yes, the diagram is right. But what diagram I want? I want DFA, not NFA. So now I need to convert. Okay. So now I have a few more example here. So the 2A will go top, the 3A will come bottom, and put together we have a whole self loop for the star. Here also same, single A will go top from the arch, and 4A will be coming here, and everything will be in the self loop. So this is single A, triple A. Okay, I hope this is will give a clarity. Again same, AB one star, union with this one, and after that this also star b star a plus b. So you just do this the same procedure only trying this. Okay. So with that, I'll stop the discussion of today's class. I'll get back to you in the next class to discuss the next thing. That is from the result of epsilon NFA, how I can able to convert the DFA using the subset construction algorithm. So that I cannot able to draw it with the mouse over the screen. That's why I have did it in the paper and I have scanned it and upload it here. So that from this I will explain these conversions. Okay. So with that, I will stop the discussion of today's class, and the next class we will have a discussion of this conversion, that epsilon NFA to DFA. Okay, so now we can leave now, and thank you for your attending, and I can leave now. Thank you.